Hello friends, welcome to the second video on normal distribution. The main purpose of this video will be how to explore the normal distribution table. Come on, we'll quickly get into action. This is called as the normal distribution table, which will be provided to you for your examination purpose by the COE office. So when it comes to the exam point of view, the table will be provided by the COE office. But when you are having your cycle test exams, it is mandatory that you have personally a copy of your normal distribution chart for the examination purpose. We will see how to read the data from this normal table. There are going to be various versions of this normal table which are available in the internet. Some of them are called as full table and some of them are going to be half table. We will now see why is the name half table given to us. When we start from over here, the table value begins from 0.000. It gradually increases line by line, and when you move to the bottom, we can see that the last value it is achieved is going to be 0.4993, which is somewhat roughly closer to 0.5. And what is the 0.5? 0.5 is nothing but half of our area. We will try to recollect the property of the normal distribution curve, that the normal distribution curve is going to be a bell-shaped curve, and the total area that lie under the graph is going to be equal to 1. So we know that the normal distribution curve is going to be a bell-shaped curve. So it is going to be a bell-shaped curve. And the total area under this curve is going to be equal to 1. What do you mean by total area? So when I am going to start from over here, from here I shade and then I move on, finding the total area over here. And when I am going to reach at this point over here, the total area achieved will be equal to 1. That's what we say, from minus infinity to plus infinity, the total area is going to be equal to 1. The second property is that the curve is going to be symmetric about the ordinate. So if this is going to be my center line, to the left as well as to the right, the total value is going to be the same because it is due to the symmetry. So how much ever is going to be the portion which is available for the left hand side, the same value will be available for your right hand side also. That is by symmetry of the data. Since the total value is going to be 1, what happens to the half of the area? Half of the area will be equal to 0.5, and this half of the area will again be equal to 0.5. That's why we call it as half area table. So now this you can see on top of it, the table always measures the data from the center. So this will be the line z equal to 0. Normally when the problem is given to us, the problem will be given to us in format of x, but this x will now be transformed to z using the formula z equal to x minus mu divided by sigma. So when this value happens to be equal to mu, what happens at x equal to mu? So when I have x equal to mu, the value now changes to z equal to 0. So mu minus mu, this will become mu minus mu, this will become z equal to 0. Okay, so z equal to 0 will now become my center line, which varies between minus infinity to plus infinity. Now in case of we want a region, then how it is measured? The region is always measured from the center line. So now you can see over here the region is measured from the center to any particular portion which we require. So if we want from the center to the point, say z equal to 1. So how to go about it? Now we will see how to find the area of this portion between 0 to 1 from the table. This is actually probability when we are talking about. So this is the probability of 0 less than z less than 1, the region between 0 to 1. So how to go about it and find is represented as the value from the center to the point 1. From the center to the point 1. Now this 1 I can express as 1.00. Now for any data calculation, write it to 2 places of decimal, out of which you can see Z over here. The first 2 decimals are looked over here in this downwards direction or in the vertical way, and then the third value will now be looked upon, the third position will be looked upon in the horizontal, like 0, 1, 2, 3 and so on. So when I want 1.00, how will to look about it? 1.0 is available here and the next value is 0, which is available over here. So 1.00 is going to be 0.3413. So 0.3413 is going to be the area between Z equal to 0 to Z equal to 1. Now moving on, let us see what is going to be the area between, say this is going to be a straight line, the curve. So this is going to be your Z is equal to 0. So say suppose I want it as 1.73. What is this area between this? So I want the probability of 0 less than Z less than 1.73. How to get this value from the table? So 1.73. 1.7 you look vertically and 3 in the horizontal position. Where is 1.7? 1.7 is over here. And where is 3? 3 is over here. So just go and see where these 2 points meet. 1.7 and 3 meet. Where does this 1.7 and 3 meet? Over here in this position. So what is the answer for this? This is 0.4552. Okay, so this will be 0.4582. 0.4582. So the value for 0 to 1.73 will be given as 0.4582. Now moving on, we will have this table one more time, and now let us see how to estimate the remaining of the data. Okay, now say suppose I want the area between probability of -2 less than Z less than 2. So where is the line now? So this is going to be my center point, which is going to be Z equal to 0. Now Z equal to, this is minus infinity and plus infinity. So -2 will be over here. Say suppose this is my Z equal to -2. The same distance over here, you will have Z equal to 2 present over here. So I will have this to be minus infinity. This is Z equal to 0. This is going to move towards plus infinity. This is -2 and this is going to be +2. So I want the probability that the value takes between -2 to +2. So what will be the region which I need to find? This will be my region of integration, or the value I want the area to be found out. Now this table where I have over here doesn't contain any negative values at all, but I need a negative value over here. So how to get this negative value? In which case we will have to make use of the properties of normal distribution. What does our property say? The curve is symmetric about the line Z equal to 0. That is, how much ever portion is available from 0 to -2, the same available portion is from 0 to 2. That is, how much ever you want to measure in the negative region, if you are going to measure the same quantity in the positive region, then these two values are one and the same. So if you want any negative value, just move on to the positive value of the same content and get a required area from over here. Now coming to this is going to be twofold of, I can write it as 2 times of, when I am going to fold it and see. So what will happen? This portion will be the same as this portion. So I can just mark it over here. So it becomes 2 times of 0 less than Z less than 2. Now it is 2 times of, so from 0 to 2, I want from 0 to 2. So find what is going to be 2.00. So where is our 2.0? 2.0 is here and 0 is here. So what is the answer for it? 0.4772. So just multiply by 2, then you will get the answer for over here. Now say suppose you want it for some other negative number. So what be the negative number? So say suppose I want it for minus 1.75 to, say suppose this is going to be 0.83. Now if I want the area between these regions, now how to go about it? This is my 0, so I split it into two portions, 1 and 2. What is this second portion? Probability of 0 less than z less than 0.83. And what is the first portion? It is probability of minus 1.75 less than z less than 0. So when I add both the area, I will be getting the required area. But this quantity is negative in nature. So how to make it into positive? By symmetry, I know that this can be converted as 0 less than z less than minus 1.75 is the same as 1.75. So now go to the table and see where is 0.83. 0.8 and 3. What is 3 over here? So this is going to be 0.2967 plus, now go for 1.75, 1.7 and then a 5 over here. So how to go about it? So it is 0.4599. Now when you add these two data, you will be getting this required data. Now moving on to the next type of problem. Now whenever we want to find the value of the curve or the probability beyond a particular region, so how to go about that quantity? Say I want probability of z greater than or equal to 1.22. Now where is going to be z equal to 0? This is z equal to 0 and this is my z equal to 1.22, and I want the region beyond it. Where is the region beyond it? So this is my beyond region. Now when you want the beyond region, you need to keep always in mind the table always reads from where? Only from the center. So I can read only from the center to one particular line, but this is going to be a beyond region. So in which case we use the property. What do you know about this half region from 0 to infinity? This half region is going to be 0.5. So if I am going to subtract from this 0.5 the portion which is available from the table from the center, that is from 0 to 1.2, then what will happen? We will be getting the required region, which is going to be this portion. So when you want a greater region, what do you mean by this? This is the greater region. Always remember it like GST. What is GST? The tax. Always when you have more than the amount of income, always it goes to the government, right? So in which case the value or the amount which you have is going to get subtracted. So when you have a greater amount, then what you will have? You will have to subtract. From which value you will have to subtract from? GST, you will have to subtract it from 0.5. So from 0.5 you subtract what is going to be the value from 0 to 1.22. So keep in mind, whenever you have greater, you subtract GST. So for 0.5 minus 1.22, where is my 1.2? 1.2 and 2. So it is going to be 0.3888, you subtract. But say suppose you want probability of z less than the value of 1.22. So what will be? Now in this case, now you can see that this table is going to be, this is going to be a 1.22. This is going to be your z equal to 0. So less than, where is our less than portion? Less than portion is over here entirely. This is going to be my less than area. Wherever it is going to be less than. When you have quantity less than your amount of income, then what happens? The amount gets saved. It gets added up to your savings account. So you keep in mind, when it is going to be less, then you add. So what you will have to add? You know that this half of the portion is going to be equal to 0.5. So with this 0.5, now you add. What you add? You add the value of 0 less than z less than 1.22. So with 0.5, you add the 0.3888. You will be getting the required area over here. So keep in mind, GST, when the value is going to be greater, then you subtract from 0.5. When it is less Less means where will the amount be? It will be safe in your savings account. So you will have to add. When the value is going to be less, you add. When the value is going to be greater, you subtract. If you keep this in mind, then all the problems will become very simple for you. Thank you.